Hello students, this is the last section in chapter 4 of our textbook, which is on circles. So let's get started. Okay, here's the equation of a circle. A bit different from the other equations we've looked at. X squared plus y squared equals r squared. And because r is the radius, r has to be positive. So if you look at the diagram of the circle here, which is from our textbook, you can see where this equation came from. What we have here is a right-angled triangle, and x and y are the two legs, and the radius is the hypotenuse. So Pythagoras basically says x squared plus y squared equals r squared. So overall, the derivation of this formula is pretty easy. Okay, a couple of questions about relations and functions. Just a bit of a reminder about those. So let's say we've got the equation x squared plus y squared equals 5 squared. Okay, is this a relation? And explain why it is or it isn't. So stop the video, have a think about it. Once you've got an answer in your brain, you could put the video back on and see if your response agrees with mine. So is it a relation? And the answer is yes, since for every value of x in the domain, there's at least one value of y. So for example, if x is 3, 3 squared is 9, then 4, for example, is a value for y, because 4 squared is 16, and 9 plus 16 adds to 25. So it is a relation because for every value of x, there's at least one value of y. Next question, is it a function? Once again, stop the video, have a think. Once you've got an answer in your head, start the video again and see if my answer agrees with yours. And in this case, the answer, it is not a function. And the reason is, to be a function, for each value of x, there must be exactly one value of y. But in this case, there are two values of y for most of the values of x. For example, if x equals 3, 3 squared is 9, so y could be 4, because 4 squared is 16, and 9 plus 16 equals 25. But y could also be negative 4. 3 squared is 9, negative 4 squared is also positive 16, so there are two values of y for that one value of x. So in this case, it's a relation, but not a function. Okay, what is the radius of the circle with this equation? Stop the video, have a think, and then check your answer. And of course, this is quite an easy question, since the formula for a circle is x squared plus y squared equals r squared, and r has to be positive, because you can't have a negative radius. The radius squared is 16, so the radius is 4. Okay, stop the video, have a think about what's the domain and the range for this function. Now, because it's a circle of radius 4, and it's centered at the origin, the center of the circle is at 0, 0, then x can be as small as negative 4 and as large as positive 4. So the domain is negative 4 is less than or equal to x is less than or equal to 4. And because a circle is symmetric, you can say the same thing for y, that the range is between negative 4 and positive 4, including 4. Okay, what about this equation, x squared plus y squared equals 15? Can you answer the same three questions, please, before you listen to my solutions? Okay, so we're going to do this one much the same as before. That must be r squared, and that, of course, means that r is the square root of 15. So r doesn't have to be a nice whole number, and r squared doesn't have to be a nice whole number either. What is the domain? Well, it's going to range between negative root 15 and positive root 15. Again, the center is at the origin, so the smallest it can be is root 15 to the left. on the x-axis, which puts it at negative root 15, and positive root 15 is the largest value. And because it's symmetric, once again, that's going to be much the same answer for the range, but instead of having an x in there, you're going to have a y. Okay, I think we're just about done with the first video. This is just a quick introduction to circles. Okay, determine the position of the following points in relation to the circle, x squared plus y squared equals 16. And by the position, what they're actually meaning is that point inside the circle, on the circle, or outside the circle? So I suggest you stop the video and see if you can work out a way of figuring that out. We haven't done it yet, but it's not all that challenging to figure out. So have a go, please. Okay, so what I'm doing here to solve it, that's x, 1.8. Oops, that's x, and that's y. So I'm just going to square x, square y, add them together, and see if the total is less than 16, equal to 16, or greater than 16. So x squared plus y squared equals 1.8 squared plus 2.5 squared, which adds up to 9.49. That's less than 16, so therefore that point must be inside the circle. So my suggestion for you is have a go on your own at question C and check the answer in the back of the textbook. And we'll stop there. Just a quick introduction to equations of circles.